we have the 3 equation. From the 3 equation, I can choose the 1 and 2. From 1 and 2, I have to solve the equation by using the what? Cross multiplication method. So here, you know very well, x1 by put it the matrix, then minus x2 divided by here is also put a matrix, here x3 divided by here is also put the matrix. So I can hide the x1 column. So what is the element here now? Minus 1, here 1, minus 1, here minus 1, then here hide the x2 column. So here minus 3, here 1, then what about next will be minus 1, here minus 1, then hide the x3 column. So here minus 3, minus 1, so here minus 1, again minus 1. You have to solve, you get it the values. So how can you solve? Now determinant x1 by, so 1 is here to 1 minus, here the minus minus get a plus, so 1 plus 1 will be read 2, 1 ins are 1 minus of here to plus 1 plus 1 will be get it 2. Similarly here minus x2 divided by 3 ones are 3, so 3 minus, here 1 minus will be there, formula will be minus, so we can get it the plus 1, so get it the 3 plus 1 will be 4. Next x3, so here minus 3 will be minus 1 will be get it the 3, so here 3 minus 1 will be put plus 1, here put it the 2. So therefore we got the 2 minus 4 2. So this will be, I can divide by 2. So if we divide by 2 now, what is the value get it now here? X1 by 1, here minus x2 by 2, then x3 by 1. So this is got the vectors. What is the get the vectors here now? So what is x3 vector? So here x3 vector will be 1 minus 2, here plus 1. So this is the x3 vectors. You know very well, x3 vector already find out the x1 vector, x2 vector, x3 vector. So this is our x3 vector. What do you find out in the x1 vector? So our x1 vector will be minus 1, 0, here 1. Then what about our x3 vector? So x3 vector will be 1, 1, 1. So we got the 3 vectors. Now we have to prove these Eigen vectors are orthogonal in pair. So what is orthogonal in pair? What is the conditions? We have to prove, have to 3 vectors. If you to prove orthogonal in pairs of vectors, orthogonal pairs for what? Vectors. How can to prove? So this is a have to condition. What is the conditions means? x1 transpose x2 equal to 0, then x2 transpose x3 equal to 0, then next x3 transpose x1 equal to 0. You know x1, x2, x3. First I can x1 transpose. What is x1 transpose will be there now? So x1, x2, x3. So I can take the transpose for x1. What is the transpose now? You get it now? Minus 1, 0, 1. You have to just transpose of the vector. What about our x2? Just you know this is x2, 1, 1, 1. You have to just multiply. So minus 1 into 1, 0 into 1 will be 0, 1 into 1 will be. So minus 1, 0, again 0. What is the answer get it now? 0. So you got a 0. So this is x1 and x2 will be orthogonal in pair. Next we have to prove x2 transpose into x3. So what you have to take it now? So here what about x2 transpose? So here 1, 1, 1. The next x3. What is x3 here now? 1 minus 2, 1. Then you have to multiply here. So what you get here? 1 ones are 1. Then 1 into minus 2 will be minus 2. So 1 minus 2, again 1 ones are 1. So 1 minus 2 plus 1. Got it, the value will be again 0. So both will be what? Here x2 transpose. Here I can prove the what? x2 transpose, x3 is also 0. So both this will be 0. Next we have to prove what? x3 transpose into x1 equal to 0. So I can, what is x3 here? This is our x3, yeah? Just take the transpose. What is the transpose here? 1 minus 2, 1. This is x3 transpose. Have to multiply with x1. What about your x1 here? Minus 1, 0, 1. Have to multiply with them. What do you get now here? So 1 into minus 1. Here minus 1. Okay. So minus 2 into 0 will be 0. 1 into 1 will be 1. Already minus 1 will be there. Minus 1 here, 0 here, 1. So 1 minus 1, 0 plus 1. Got it, answer 0. So finally what you have to prove here? x1 transpose x2 equal to x2 transpose x3 equal to x3 transpose x1. So all will be multiplied, get it to what? 0. So this will be x1 transpose x2 equal to x2 transpose x3 equal to x3 transpose x1. You got the 0 value. This is called what? So finally we have to verify it. So all the three vectors x1 and x2 and x3, these eigenvectors are orthogonal in pairs. We have to verify it. Orthogonal in pairs. That's all. So this is our proof. We have to verify it. x1, x2, x3 are orthogonal in pairs. That's all.